Hey guys, so we are going to be talking about dihybrid and gene linkage. So, dihybrid and gene linkage, these are some really fun words. Dihybrid literally just means that I am looking at two genes that are going to produce two traits. That's it. Gene linkage basically means, are these genes connected? Okay, so when genes are linked, okay, so linked genes. Linked genes are basically two genes close together on the same chromosome. Okay, so let's say I have pair from my karyotype, pair 1. Alright, chromosomes. Let's say I have two genes. Okay, I have one gene here, and I have, that's going to be on both chromosomes. It's going to be in about the same place. Well, it would be in the same place. And then I have another gene that's right here. Okay. So these are super duper close together. What that means is that even during meiosis, when genes are kind of flip-flopping and crossing over, these genes are most likely to travel together. So what that looks like is that my offspring, this will result in offspring having very similar traits to parents. We're going to go through an example to this so that we get out of the abstract and into things that actually make sense. Okay, so my example is that a geneticist crossed dogs to determine whether two traits are linked. So two traits, talking also about genes. So remember, genes turn into traits. Traits are just characteristics. Alright, the geneticist crossed a dog with brown fur and flappy ears. Okay, so that's little b, so the homozygous recessive all along, with a heterozygous dog that has black fur and straight ears, and this is heterozygous all around. So what this looks like, honestly, on the chromosomes would be that on each of the chromosomes, so one chromosome, remember your pair or your karyotype, your pair of chromosomes, you're getting one from mom and one from dad. So let's, I don't know, think of dad as the brown fur and flappy ear. So this would be his chromosome. So I would have brown hair and flappy ears. And then mom has black fur and straight ears. Okay. So like I said, even if these chromosomes are going to like flip-flop during prophase 1, the gene part, these genes are actually going to stick together. Which means that the majority of the kids that these dogs produce are going to look like them. Meaning, most of them are going to have brown fur and flappy ears, or most of them are going to have black fur and straight ears. Now, there are a couple of instances, right, where like these could actually recombine, so not 100% of them are going to look like the parents, but it's very likely. So we're looking to see if genes are linked. Okay, so if genes are linked, when I'm looking at the phenotype result, I'm going to have a lot for my parent phenotypes and much less for anything different. When I do a dihybrid cross, it's pretty normal that I get 4 different phenotypes. If I look at my multiple choice problem, my phenotype options are black for straight ears, which remember was my mom, black for flappy ears, that's neither parent, brown for straight ears, neither parent, or brown fur and flappy ears, which was my dad. So the way that I really determine this is if the number is over 100, I put an up arrow to be like, this is a lot. I notice that all of my arrows are up, so that means they're about all the same. That doesn't go with what I stated. Here, I have a lot. This is 230. I have not a lot, so I put a down arrow. This is less than 100, and then a lot. Okay, I have a lot of children who look like my parents, because these are my parent phenotypes, and then not a lot for other phenotypes. So this is looking like my option. I have 2 up arrows and I have 2 down arrows in the middle for my things that aren't, for my phenotypes that aren't like my parents. Let's make sure that all the rest. Okay, this is over 100, this is over 100, over 100, over 100. All of those are a lot. There's no variation. No. Okay. Now I have not a lot, not a lot, not a lot, not a lot. All of those are below 100. I don't really see a clear difference between my parent genotypes and other things. That's not it. I already determined these are 4 up arrows. That's not it. And look at that, I was right. Okay, so that was all about gene linkage. So much fun. So you can just practice on the next one. Have a good time.